Okay, so you're into the statistics unit, right? It's statistics light because it's a geometry class. We're prepping you for a possible future statistics class and maybe trying to catch your eye where you may decide to go into statistics as opposed to some of your other math options in high school. I'll keep saying to you, I think statistics is very valuable. A lot of math, I don't know if it will be so useful to you in your careers, but statistics will. In my engineering degree, I took a statistics class, right? Because we were measuring all kinds of types of part failure. Everything was numbers, everything was data, right? If you have, I remember one of my professors talking about the failure of an airplane tire, right? You've seen those big airliners land. Have you seen the wheels, the smoke that comes off when the wheels touch the ground and they start spinning instantly, right? They smoke a little. Imagine the forces on those wheels, right? The wheels, the struts, all those things have to be tested with data. It's the tests that then come back and allow us to build them safely. Every bridge went through some process of its materials being tested. In my civil engineering degree, we would take cylinders of concrete and crush them in a giant machine and measure how much force they could take. How else would we know what concrete to use on a bridge or building? Does that make sense? All that's data, all that's statistics. So I would argue to you, it doesn't matter what profession you're going into. Then I went into business in my MBA. Statistics, why? We want to know what's happening in business. We want to know what's happening with products, right? Walmart does a very sophisticated process in their information system for deciding when to stop taking shelf space for a product. If sales are like this in their data, they don't take the product off the shelf. They leave it on the shelf. It's good. But if something happens up here where the data starts to go like this, they may be thinking, I could put something else on that shelf that sells better. It's a big deal. It's your whole world when you're in business, right? Everything comes down to the finances, how much they're making, so they can pay their investors. Okay. My third degree, education, right? We're looking at students. What is happening with learning, which is very difficult to use numbers with learning, but nonetheless, we still try, right? We're trying to look at test data. We're trying to look at what is being absorbed by students and whatnot, right? So just the idea that statistics is hugely valuable for any field you go into, and therefore I think it's a great math, maybe more useful than a lot of the other maths we're now teaching. So let's go through two types of data representation today. One is called and I kind of forget, is this statistics number 2? Let's call this stats for statistics number 2. All right, we're going to look at two representations of data. One is a box and whisker. Am I spelling that right? Graph or chart. And the other is a histogram, the famous histogram, which probably goes back into, you've heard of before. Sorry, it takes my spelling brain a second to warm up here. So, graph, or let's say plot. All right, we're plotting data. So here's the box and whisker plot. When you look at this right here, if you can see it, do you see why it's called a box and whisker? Right? I always think of, when you hear whisker, what do you think of? This is the best I got. How do you make the nose? You do something like this or something. Something in there, right? I don't know. You guys, okay, I don't know. Something like that. Okay, box, right? So here's your box. Let's draw this. There's the box, and it's got some lines in it. It's got a line here, and here, and here. And these lines can move as well as these move, depending on the data. This is a way of taking a large mass of information, data, and then trying to show a picture of it so that your brain can start to wrap itself around what the data is doing. On this box now are these two things, right, that go like this and go like this. They can be, every one of these distances will be controlled by the data. And so when you look at that box and whisker, your brain goes, something might be happening with the data. The cool part about data is a lot of times they'll take patterns, right? We as humans are very patternistic. And so is the globe, by the way. You ever go to the beach and watch the waves, right? you see the patterns that roll through those waves, and you'll see them shift back and forth. And if you're out there playing in the waves, some waves break this way, some break that way, but then they start to repeat, and you're like, wow, I've seen this pattern before, right? So data in our world as humans starts to do certain things that becomes, we're like, oh, I recognize this, right? There's a whole field when you're investing in stocks. It's called charting, and these are people that do nothing but look at the chart. They look at all the data, and there's all kinds of double dips and triple dips and everything. They have a name for everything that happens in the chart, and they look at this happening, and they go, now I think this is going to happen, so I'm either going to buy or sell that investment, right? Same thing with data. Now you're looking at different ways to represent it. So let's talk about the parts of this. These are labeled different points. There's an A. This one point's going to be the B. There's a point in here. C, D, and E. Along the bottom of the box and whisker, like this, we'll call this F. And we even have G. Let's start with that. There's a title. So there'll be a title on the box and whisker plot. And the title in statistics is really important because it'll say something about what you can expect to see in the data, right? I mean, if it said the failure rate of airplane tires for the Boeing 737, right? Now your brain is starting to understand a big picture about this data. You kind of know what to expect. Something's going to be showing how often this tire fails, right? Or the strut, or whatever part we're examining. So the title becomes important. F is the number line. So everything up in this chart is fitting to a scale and numbers on the number line, right? And I love the number line because it goes back to one of your basic early learning experiences in math. One of your very first things was the number line, right? Number lines will often have, zero and positive and negative numbers. In this case, it may or may not be that way. It kind of depends on what they're illustrating. And so let's go through the parts. First, let's talk about C. This is the mean. What's another name for the mean? What's another name for the mean? Trust yourself. Okay, average. Okay. Sometimes you feel like you're sitting there, you're like, I think I'm going to say this, but then no, because I don't want to risk it, right? Okay, so that's the mean, right? So what we're talking about is data always takes this sort of centrality, right? When we talked about the first lesson, we were talking about measures of central tendency, right? A measure of central tendency. ANSI or NC? I'm not sure which. ANCY or ENCY? Tendency. ENCY? ANCY? What is it? What is the data tending to do? And where is the center of all the data, right? Like we looked at before, even if you think of, remember that word outlier we learned on the last one? There's all this data going on in here, right? And it all starts to accumulate somewhere. Us humans and waves and everything else start to go, oh, there's a lot in here, right? So this thing starts to take on some sort of centrality. Most of the data, 80% of the data, is starting to arrive at one point. The outlier was out here. Sometimes we'll erase those. I'm going to ignore those, right? The same thing is happening with this representation. You can see how the box forms a centrality here. You can see where the mean is within it. Now the mean's a little off center on this box. I drew it that way on purpose because that would say that this data, see how this curve is kind of moving over to the left a little here within itself, right? So you get to see where this thing moves. Then there's quarters of data we talk about. So if this is all the data, we talk about a 25% of it being a quartile, which is a quarter of the data. So this box starts to represent the quarter of the data above the mean. This box here represents the quarter of the data below the mean. This whisker represents the quarter below that quarter, right? 1, 2, 3, 4 quarters. It's the whole set of data. This makes sense? And notice how even with these, you start to see these tails dropping off, things going out like this. Here's where the whiskers start, maybe this whisker is even longer. It's going out like this, right? That's starting to explain that same idea with this different picture of the data. So, A is the lowest data point. This would be lowest or least. This would be highest data point, or the one of the greatest value. This would be the quarter value here, so this would be the quarter in, the half, the quarter, and the upper, right? So half being in the middle. Okay, they call this, and there's some names, this is not only a quartile, this is the upper quartile because it's right above the middle. This one, therefore, would be the lower quartile. Right. Upper quartile. These are, of course, called, I didn't say it, these are, of course, called the whiskers of the Whisker plot. And that's why the cat face looks really irrelevant to me. Oh, the cat face. Highest value, lowest value, upper quartile, lower quartile. Interquartile range, I like that word. So BD. This box here is the interquartile range. So representing half of all data right here, right? And you can look here where this is somewhere in here is a 50% number of the data, plus some more as we start to think about additional parts to it. So let's see what else we got. Median, number line, whisker, title, center weight, BCD. This whole thing is also called, the interquartile range is called the center weight. Just think of how heavy the data looks right there, right? It kind of looks heavy to you from that box. That's where this central thing is starting to happen. It's a little bit off center, a little bit skewed here. It's not exactly in the middle, so it's not totally symmetrical, but getting close. Okay, and then, so let's kind of talk about draw two quick representations. This would be here's our number line. Here's our box way down here, something like this. Does it make sense to you that this would be a left-centered box and whisker plot? So you start to see patterns. This would be a pattern. All the data is skewed over to the left side of whatever we're talking about. Maybe that's a low number of failures, right, of your tires. Maybe your tires over on this side of the chart are a low number of failures. What would be the opposite of this? Here, and this would be a right-centered box and whisker. So maybe in this case, you've got a high rate of failure. Okay. And then for the histogram, this one is very generalized in this lesson. Just to cover it really quickly. Again, let's say we have a histogram. Histogram looks something like this, right? It's got these bars of data, right? These represent data, and it tails something like this, right? This starts to look a lot like this one here in terms of this histogram is left-weighted. And then the opposite of that would be true if it's lower up here front. Right? This one is right-weighted. Again, maybe back to that airplane tire. Maybe one is representing a low degree of failure, the other is representing a high degree of failure, right? Part of when I was in engineering school, one of my good friends was, we had these internships. You get hired out of college. You're in college, you're taking classes, and then every other quarter we would be hired by an engineering company and go paid to work. And they called us interns, right? But they paid us. I don't know, I got like $10 an hour or something. It was awesome. So one of my good friends was hired by Disney down in Florida. So she would go with her engineer, you know, she was an intern. So with the engineers at Disney, they would go ride the roller coasters every single night. And they would put sensors on the roller coasters to measure stress, right? So they would then chart out how much stress was in each of the turns and the curves and every part of it. And it was a legal problem because Disney would get sued by people who would get injured on the rides. They would say, your ride did this to me, right? So they had to keep regular data on the stresses the roller coasters were causing on people as they were rolling through. So they would spend their nights riding the roller coasters at Disneyland. Can you believe that? That's what engineers get paid to do, if you can believe that. So, and this would be, you know, a case of where's the amount of stress, how much is it coming through, and there's different sensors that we use for all that. And they would chart it on a computer, which would put it into a table, and then they would store that by day. Sometimes the rides would change over time where they weren't maintained as well or they needed maintenance, right? So they'd go back and fix that. So, okay, so it's statistics light because it's kind of just bringing you into the world of how do you represent data. It's not even doing any calculations, right? It's just getting you into the mode of here's kind of how it looks and maybe in the future then. And again, in Dr. Shee's class, he uses a program so the data crunching is done by your device, right? You do some basic hand calculations, but you're going to have computers do all this crunching for you. So kind of a different understanding of using numbers to get information rather than I'm a mathematician, right? I would say engineers use math more to create a result, rather mathematicians use numbers because they love numbers, right? They're studying the actual numbers. So that's sort of a different application.